So, and next speaker is Daniel Ehrenberg, probably. Yes, great. Or more importantly, Little Dan, as everybody knows him from Twitter and GitHub. So welcome back on stage. Welcome on stage, Daniel. And he's going to talk about AsyncContext, observability in JavaScript through TC39 and WinterCG. And, welcome, Daniel.
Hello. Hello. Thanks, everyone. So, as Matteo said, I'm going to talk about AsyncContext. So, I'm Daniel Ehrenberg. I work at Bloomberg now on our internal JavaScript framework. I used to live up there, outside of Barcelona, near the coast in a little town called Las Roquetas de Garraf. Fun fact: I'm learning to play the accordion, and professionally, I'm a TC39 delegate. TC39 being the JavaScript Standards Committee. I'm also a member of WinterCG, as Nicolo and Andrei mentioned this morning, the body that's working on standardizing server JavaScript environments. And I'm vice president of Ecma International, this body that kind of oversees TC39. So I want to talk about distributed tracing. This is what Steven Belanger was referring to earlier in his talk on Monday about making logging work for distributed applications. OpenTelemetry is one popular implementation or scheme for implementing distributed tracing. And the goal is to make it so that a single request can be visible. When you have a request that's in a distributed application that goes between multiple servers, it can be hard to associate what's going on the different servers with each other. So there was a paper in 2010 by a number of people at Google called Dapper about their distributed tracing implementation. And it relies on this idea called span IDs to rebuild the tree of things that went through the application based on logging just on individual machines. So if you think about a distributed application, maybe you have, say, a flight search application, and it's slow, and you want to figure out why it's slow. So what happens is you have your user, which is the website. It calls into A, the front-end server. Maybe A calls out to B to look up the user session. And then it goes back to A and dispatches out to C, which dispatches to D and E to implement the flight search, to look up in a few different data sources. C then collects the results. And it takes like 5-10 seconds. You're trying to debug it. So what you can do with OpenTelemetry is each of these servers has a log. So the log for A, B, C, D, and E here. And those servers log spans. They log when something starts, when something ends. And the logs contain a span ID. It's just kind of a generated ID. Could be a random number. Then this is sent for each request that goes to an RPC to another server. That span is sent, and based on all those different events, you can reconstruct the tree of requests, and in particular, how long each part of it took. So then that sort of collecting everything together happens after the logging and doesn't need to make the request processing take any longer. But the question is, what's the current span ID? So you need this for both your log messages and for attaching to the RPC requests to make it so that they can be printed as part of the log messages for the child so that the tree can be hooked back up later. You'd think, well, maybe store this in a global variable. But this doesn't work because in a system like Node.js, you have a single thread handling multiple different requests and going back and forth between them as asynchronous I/O completes. So it can look like this. You start one request, it's red, then you go to blue, and you have to go back and forth. One solution that's mentioned in the Dapper paper is to use a thread local variable. So thinking about Nicolo and Andrei's talk, when they were talking about how servers worked in the past, or still the present, this is still used. You have a thread per request, and that can store the local state of the request. You can have what's called a thread local variable, and that can store the span ID. It can store things about the user session, and this is what the Dapper paper mentions. Node.js's solution is different because it needs to account for the fact that we don't have any kind of thread local storage. Instead, we have async local storage, which is sort of the equivalent. You can import it from a module called async hooks, then make a new variable with the async local storage constructor. From that, you can get its value. It's initially undefined. The run method will set the async local storage during the callback to a particular value. So when it starts, it's 1. Instead of RPCs, I'm using set timeout. And when you queue something with set timeout and it runs later, well, the value of the variable gets restored, even though that happens 200 milliseconds later. But we can also have another concurrent request, which is we're setting the ID to 2. And when you get the store, it's 2. Even when you delay another 200 milliseconds, it's still 2. But what this means is that in the linear timeline, it's going back and forth. Initially, it's 1, then it's 2, it's 1 again, and then it's 2 again. So before I go into how this works, I want to caution people to not overuse async local storage. The point of this talk is not to explain, yeah, everyone, make a bunch of async local storage variables and integrate it into your application. You should probably be integrating distributed tracing, maybe OpenTelemetry into your application. But async local storage is more of an expert feature. It's more useful for libraries and frameworks. If you do need to use it, you probably just need to use 1 or maybe 2 variables, because you only need to change to a different variable when you're changing what the scope is of how frequently you change what the variable's value is. You can use an object that has multiple things in it to point to different aspects of it. And the Dapper paper explains this. The strong claim that's made in that paper is that it's possible to do distributed tracing while changing just a few libraries. In particular, we need to change sort of the RPC libraries, both for exposing yourself as a service that responds to requests, and for making RPCs out to callees, because those are the points that are most important. In practice, there end up being a lot of these points in different libraries, but still, these days, APM vendors can instrument just a certain number of libraries, and it ends up implementing tracing for the application. So in general, when you're writing application code, you have variables, you have parameters to functions. That's probably a better way to pass around information than async local storage. But when you need it, you need it. Just look. So some data structures that are used in async local storage. Well, really, there's just one data structure. There's a map mapping those async local storage objects to values. So for example, the value in the previous example was just a number, like 1. And you have a global variable that points to that map. The run method, which takes a new value for the variable, as well as a callback. The first step is it clones that map. It sets that one entry in the map to another value. Then it sets that as the global map variable. Then you can run the callback. After it's done, even if an exception is thrown, it's important to restore the previous map value. And when you hear clone, it sounds like it might take a long time. But libraries like Immutable.js show that clones can be fast. You can use classical, they're called purely functional data structures. There's a great book on this by Chris Okazaki that you only have to copy part of the data structure if you're trying to clone it and make a little change, if you implement the data structure well. So run is how a variable is changed, but how does it work in set timeout? Set timeout has to save and restore that pointer to the map so that then the map can be restored when the set timeout callback runs. There's a function called async resource.bind, which serves this purpose. The whole thing also works with async functions. So if you use the promise version of set timeout, then you can await set timeout, and the store still returns the value you expect. And it's just all the same as with the callback version. The timeline still goes back and forth like before. So how could this be implemented? Maybe we could do this by monkey patching promises. When I talk about this, this has actually been implemented in real production code with monkey patching multiple times, for example, in Zone.js. So the idea would be, you have promise prototype then. Ultimately, await is just a nice syntax around promise prototype then, right? So you set then to something that takes the then and the else callbacks, wraps them so that they will restore the map properly, and you're off to the races, right? Well, it turns out you can't. You can't monkey patch await. You can monkey patch then, but when you have an await statement, it's always going to call the original promise prototype then. You can see this in the JavaScript specification, because the await keyword takes an expression. So then on step 3, it calls the await function. That's like an internal algorithm. Then that always creates an original promise, like a built-in promise, out of what's passed in. Then it always calls the built-in promise then algorithm. So it's just not going to go through the code path to restore the map. Oh, record scratch, freeze frame. Oh, that's me, the JavaScript standard. How did we get here? Like, why are we in this situation where monkey patching doesn't work and where the APMs are broken? Well, let's talk about how async await was added to JavaScript. First, as described in the previous talk about CommonJS, promises became popular in the JavaScript community, and simultaneously they were needed for web standards. So the promises A+ community effort happened, and that ended up becoming promises in ES6. There were some little differences, like microtask scheduling. There are other differences in kind of how the then method becomes chaining, but it's not so important. Async await became popular in Babel. It didn't make it into ES6 because there were still some debates ongoing. But in 2017, it was standardized. And there was this difference about the strong semantics of await, making monkey patching not work. Sometimes people wonder, was this an unintended consequence? Was TC39 not thinking about Node? Well, so the committee had a goal to give reliable behavior to syntax. When you see an array literal, you know it's always going to create an array. So the idea was, when you see an await keyword, you know it's always going to await. It's not going to do something else. There was this issue where Node.js was not sufficiently represented in TC39. Today, Node is directly represented via the OpenJS Foundation. There are a number of Node collaborators, including Guy Bedford, who attend TC39 regularly based on their OpenJS affiliation. But even at that time, many people in TC39 cared about Node, and were trying to make sure that things worked out well for it. For example, the V8 team, V8 being the JavaScript engine that runs inside of Chrome, wanted to ensure that V8 also worked well for Node.js. So the promise hooks API was created specifically to allow Node to monkey patch promises, even though JavaScript code in websites couldn't. There was also a thing where Angular wanted to monkey patch promises. They used Zone.js in their reactivity model, at least before their big release just earlier this week. That was the encouraged reactivity model. And the suggestion was, well, just keep using Zone.js, just transpile async await back away into calling promise prototype then. A little bit unsatisfying, but so if you look at the V8 API, there's no web API that you can call to get at promise hooks. You have to go into the way that V8 exposes itself to C++. So this is the way that it hooks into Chrome, but also the way that it hooks into Node Core. it takes these 4 different functions that you can trigger to be called when promises go through various stages of their life cycle in order to save that map pointer and then restore it at the right point. That's implemented in JavaScript. But there are a number of problems with how this works. So one is that promise hooks are slow. Having those hooks be calling out to arbitrary JavaScript code was influenced by the previous design of async hooks. Async hooks was this more general mechanism that allows you to hook in different kinds of code, which at the time we thought was needed for application performance monitoring. It turns out all we really needed was async local storage, but that wasn't really clear at the time. Another issue is that promise hooks are V8 only. So as people work on various different engines for running JavaScript on the server that might not always use V8, such as Bun, it becomes a little bit awkward. Should everybody make a promise hook style API internally? More broadly, async local storage is a node-only API. At this point, because it's so important for performance monitoring, it is being copied by other server environments. But it would also be useful in web browsers. And it would be nice to have a standard instead of each server environment making its own little flavor of async local storage. So for OpenTelemetry, OpenTelemetry tries to support clients, but the implementation, the instrumentation for clients is not totally complete. One part of this is the events not being complete, but I think another part of it is the propagation of spans. So for the performance issue, there's a new change in V8. Actually, it's not that new. It's from 2020, where there's this API called get and set continuation preserved embedder data. That's an extremely long word, but it basically lets you have a pointer that gets saved and restored across a wait. And this is the key that can get you a working version of async local storage without as much runtime overhead. But really, there's more to clean up than that. So back when I was working at Igalia, we had an offsite in this place in the northwest of Spain called Las Islas Cíes. And when you go to this island, it says there aren't any trash cans on the Las Islas Cíes. They kind of mean like pick up your own trash. So these islands actually were heavily mined for minerals, and they're a lot smaller than they used to be, but now they're recognized to be a natural treasure and preserved as much as possible. So the TC39 created this situation of difficulty implementing performance monitoring and distributed tracing. We should kind of pick up our own trash. So from async hooks, TC39 is making AsyncContext, which is basically the same thing. So if you look, it's just the name of the constructor changes. You call get instead of get store. Overall, when we make something that's built into JavaScript, for one, we can't use modules. There was an effort to make built-in modules in JavaScript, but so far that has really stalled in standards. So anything that's built in will be a global. Also, the names of the constructors changed a little bit. And we've removed some methods that were kind of poorly designed in async local storage, such as enter with. But really, it's the same thing, but built into JavaScript, so it can be implemented well, the style of continuation, preserved embedder storage. Anyway, what does it even mean when I say that something's becoming standard? Well, I keep mentioning TC39. This is the JavaScript Standards Committee, part of Ecma, and we bring together these different stakeholders in the JavaScript world. It's an open committee that people can join and participate in. So for example, we work on GitHub. We work on this thing in the top, the JavaScript standard. It's just an HTML document you can make pull requests to, file issues against. We also discuss things at meetings. We discuss the language changes. We work on building consensus. TC39 proposals go through a stage process. So first, an idea is put under discussion. then we all agree that we want to do this, and we have a first draft articulated to share. At stage 3, something is ready to go. Ready to be implemented. We have a very solid design that the committee is happy with. At stage 4, we have multiple implementations, as well as test 262 tests that can be applied to any JavaScript engine. And it's time to put it in the standard. So right now, AsyncContext is at stage 2 in the standards process. The committee has kind of agreed that we kind of want to do this if it's possible. We have a first draft. We're iterating on it. We'll see if it's possible to follow through on. Stage 2 doesn't mean it's definitely going to happen. But it's rolling. So WinterCG is a standards effort to unify server APIs for runtimes based on trying to align them towards the web platform. This is something that we're working on in Bloomberg with Igalia and with all these other members of WinterCG, in particular by sponsoring Andrea Botella's work on specifying and implementing AsyncContext. WinterCG has these various work streams. One of them is fetch. There's this cool logo. So the WhatWig fetch is this green bone, get it? And then WinterCG's logo is this, this pink circle, so pink bone. It's a pretty cool idea. Anyway, we meet every month on Zoom. It's an open call that anybody can join. And some of the things that we've been pushing in WinterCG are about new web APIs, such as response.json, that are important for server environments and also make sense in browsers. And AsyncContext is another one of these, because AsyncLocalStorage has been understood to be such an important need for servers. It's really uncommon, and that has informed the direction of AsyncContext. So one important thing that WinterCG is working on is the minimum common API. This is a set of web APIs that all things would need that we expect to be kind of a minimum basis for web environments. Maybe one day this could be extended to mean this is what WinterCG compliance means, but we haven't actually fully defined that yet. For AsyncContext, it's being defined based on the collaboration of multiple different standards venues. In WinterCG, it was identified as a common need across server environments. And in TC39, that's been brought into, we understand that it's fundamentally useful across client and server. So these are places that we can consult with different stakeholders in the server and in the general JavaScript space. In WhatWig is the place where HTML is standardized. And HTML means not just the markup language, but the way that all of the web kind of integrates together. So because AsyncContext touches things like set timeout, which is defined not by TC39, but defined as part of the JavaScript, part of the HTML standard, part of the way that the web works, that's the place where it needs to be described that it gets saved and restored. There's also the W3C WebPerf working group, which has been a very important place for improving the diagnostics and improving the sorts of measurements that you can do for performance so that people can improve the speed of websites. It's all these different groups working together rather than one being like sort of the sole owner that make these standards efforts work. So AsyncContext is at stage 2. It's in progress. We have a draft implementation written by Andrea Botella and Zhengcheng Wu from Alibaba. We need to prove that it can be implemented in a way that's fast enough that it won't hurt performance. And the implementation is being based off of something analogous to continuation preserved in better data. But still, some more details need to be worked out, especially in terms of how it works together with the web platform. So you can get involved too. You can comment on the AsyncContext repo, join our chat room. You can write tests for this. These are tests in progress. It would be great to work with all of you on this, any of you on this if you're interested. There's work ongoing implementing AsyncContext in V8, but it can be implemented in any JavaScript engine as a test. We're also working on improving documentation. So these standards bodies, TC39 and WinterCG, are both open to participation. And please contact me if you're interested in mentorship resources for these. So thank you, everybody, especially these core contributors to AsyncContext.
Awesome. Yeah, so we have a couple minutes for questions. I did want to just make one point that the async local storage exists now. AsyncContext is coming later. WinterCG actually published a subset of async local storage that if you can start using today, if you use it that way, it should be compatible with what AsyncContext, so the transition will be a lot easier. So
yeah, thanks so much, James, for writing that.
Yeah.
But immediately after that was published, it turns out that server environments are implementing little supersets of it that differ from each other.
Yeah.
So standardization is still a good thing to do on top of that, but that's a very helpful basis.
Yeah. All right, any questions? Got any? All right, so go ahead and did I miss any hands go up?
Okay.
Okay. All right, thank you.
Thank you.